Hello again. The sharkC64 language supports now function parameters and call chaining. Let's have a look. Let's open the newest example. It shows how function parameters and call chaining is used in a program. But before we have a look at the implementation, let's run the program to see what it does. The program moves large colored blocks on the screen. The blocks bounce from the edges. Also, some of the blocks go underneath the other blocks. This is a brute force implementation where the blocks are drawn with colored characters. There are no sprites involved. Because of this, there's always some visible flickering at the edges of the blocks. The flickering is caused by a delay between the erasing and the drawing of a block. Now let's go back to the implementation. The main program consists of several functions. The moveByColumn function computes the motion of blocks that move horizontally. Likewise, the moveByRow function computes the motion of blocks that move vertically. The erase function erases the edges of the blocks and the draw function draws all the blocks. The erase and the draw functions show how call chaining is used. Both of these functions call the functions of the block module. In the call chaining, the module name of the function is not repeated. Instead, the function calls are concatenated with a period. This makes the code more readable. You can also chain function calls of the module itself. If we look at the main body of the program, it has an infinite loop that calls in sequence the functions of the main module. Let's now have a look at the block module. It is responsible for erasing and drawing the blocks. In this module, in the drawBlock function, there are three parameters that determine how a block is drawn. The left and the top parameters determine the leftmost top corner of the block to be drawn. The color parameter defines the color of the block. The drawBlock function draws always the entire block. However, it draws the block only if the current color on the screen has a lower value than what is to be drawn for the block. Because of this, some of the blocks appear to move underneath the other blocks. The erase function erases a single character from the screen. The column and the row parameters determine which character is to be erased, and the color parameter defines the color of the character to be erased. So a character on the screen is erased only if it has the given color. Then the background color is used for erasing it. As the erase function erases only a single character from the screen, the erase column and the erase row functions use it for erasing the edges of the blocks that move either horizontally or vertically. Both the main module and the block module use yet another module called the screen module. Let's have a look at that. The screen module defines memory locations for character and color values on the screen. It also provides a function for clearing the screen with the given character and color values. So, as you can see, there is quite a lot going on already in this example. It is nice to see that the sharkC64 language is already capable of capturing this level of programming complexity. As for how the function call parameters are compiled, let's have a look at the erase function in the block module. The parser and the binder were extended to recognize function parameters. After binding, the translation to the intermediate representation language looks like this. In the translation, the function parameters are in fact defined as specific module variables. In contrast to the function variables, the function parameters are accessed outside the function definition. Their values are always set in the function call. However, this is the only difference. Because of this, the bytecode generation has no new elements. So, in this case, the bytecode looks like this. As for the function call chaining, the binder was extended to recognize the use of a period for this purpose. Technically, the binder was extended to remember the module name from the first function call. It is then used to autofill the module name for the chained function calls. This is merely syntactic sugar for the function calls, and it is completely resolved during the binding phase. So that is what the function parameters and call chaining looks like in the sharkC64 language. As for the next step, I will improve the development environment. I will be adding support for multiple open modules. Until then, thanks for stopping by and see you soon!